Hello, everybody. I'm David Mauro, lead iOS developer at BuzzFeed, and I'm here to talk about Mattress, which is our first open source iOS framework. And this is hopefully the first of many. This is like part of our approach to start more of a framework-based development in our iOS apps, and also on the Android side as well. And so this app, or this framework, is specifically for caching web pages offline. So it'll cache an entire web page for offline consumption later when you no longer have a connection. So why would you do that? Like, why would you need to preemptively cache a web page? And the first use case, obviously, is like you want to read this page later, and you're not guaranteed to have an internet connection. Or if there's even just a user expectation that it will load instantaneously, we want to cache that. And additionally, we want to guarantee that this cache will not be overwritten by the normal usage of your cache when you're using a UI web view to browse other articles in the meantime. So say you save something to your favorites, and then maybe a week later you go back there. So we want to be able to store that in the cache, make sure it's safe. And additionally, you might want to view the articles a little bit faster. Where is that? There we go. Faster loading, even if you're online. And this is to sort of make up for being a web view. You know, there's sort of an expectation from users that apps are native and that they are fast, work offline, just a lot faster than using the browser. So Mattress was like part of our efforts to make our apps more responsive to users. There are two major hurdles when trying to create this framework. The first is like, how do we download an entire web page? That's actually kind of tricky. A web page is made up of dozens, hundreds possibly, of requests, and we need to find all of them, which is sort of tricky, and then also save them all. And then after that, how do we then provide that content back to our browser that we're using? And so first we'll talk about downloading the web page. And there are two very imperfect solutions to this. And the first is to use UI web view, which obviously is non-ideal. It runs on the main thread. It's gonna also render everything, so it's a little resource intensive. But on the pro side, it's designed for this. Like, this is what UI web view does. It goes through the HTML and like grabs all the request it needs, parses the JavaScript, et cetera. And it's a really simple API. We just tell it, hey, here's URL, please download this. The other option is to manually parse the HTML, make that initial request, parse the JavaScript. Actually, you really need to run the JavaScript because who knows what's going to happen, what kind of network connections that's going to kick off. So basically, at that point, you're building a web browser. That's a really bad idea. So we'll go with the lesser of the two evils of using a UI web view. So our download approach looks like use a UI web view. We just kind of hide it. We don't need to show it to the user. A lot of times this will be running in the background anyways, so there's no visual aspect. It's just using the guts of the UI web view to download all the contents. And then we use NSURL protocol to capture all of these requests as they come through. And we save the responses, and we just need to associate those with the parent URL. And we're going to additionally save these into a special offline cache. This is what I talked about before, with it being distinct, so that it's kind of precious. And you might ask now, like, why don't you want to use WK WebView? And the answer to that is really simple. It doesn't work with NSURL protocol. And if you think that's really annoying, I recommend that you file a radar that WK WebView hook up with NSURL protocol so you can capture its request. Right now you can't, so we're stuck with the old UI web view for now. So the next challenge in downloading these is saving these requests to disk, or the responses rather. So the first thought is you make an NSURL cache, and you make a second one, right? You have your standard URL cache, and you make another one. But actually, there's a little bit of a bug in NSURL cache where you can only have one. And this, not just the global, like shared URL cache. If you make a second one, it actually really confuses the system. And so just kind of can't do that. So what we had to do was make a special disk cache, which is fine. We don't need in-memory cache for this because typically this isn't even going to get used until another run, or it's going to happen in the background thread, and it'll get pulled in from the disk later on. So memory is not an issue. So how do we save the files and keep them associated with the URL? Ideally, we would just use the URL as the file name. But here's an example of a URL if you go to newyorktimes.com. This is one of the many resources that gets loaded. It's truncated, as you can see, way too long for a file name. So we use CommonCrypto. We hash the URL. That gives us a unique file name, more or less, that is associated with that URL. The problem is CommonCrypto and Swift in a framework is really difficult. They don't get along well. What you have to do is create a little wrapper, kind of like create a CommonCrypto framework wrapper within your framework. And luckily, my coworker, Kevin Lord, did a lot of this work for me, which was really helpful. Prior to this, I was just truncating the URLs, which led to a lot of errors, but it was like a placeholder. But now it works great with CommonCrypto. So the next problem is, how do you know when a page is done downloading? That's actually like kind of a tricky question. You could return true as soon as the UI WebView delegate is told, did finish load. But that gets called more than once, and there's not necessarily an expectation that you're really done or what the user would consider done with the first time it gets called. So you could check the DOM ready state, document ready state for interactive, but then you wouldn't get images loaded. You could try complete, but then you might have other needs like lazy loading images, or you might want to run custom JavaScript for some reason if you say you're loading your own pages on your domain and you have certain triggers you would like to activate. So what we did is actually pass the buck on to the user. So Mattress has a delegate pattern where it will it'll actually ask you, say, hey, we've just been told that it finished loading. Here's the web view. What do you want to do? Are we done or not? And that's worked out pretty well. That allows us in, for instance, the news app where we use this to say our typical usage is when the ready state is complete, we'll say it's done. And it gives us the option to trigger lazy loading of images on the BuzzFeed.com domain, where we know what that JavaScript looks like. So next, how do we provide this cached content back to the UI WebView? We've successfully downloaded it, and we have it stored to disk. We now have to dig into NSURL protocol, which is kind of a mess. It's a little scary. But each time anyone requests content, and again, except for WK WebView, unfortunately, but anytime the UI WebView is going to request content, it'll go to our cache and ask it if we've registered with the protocol. And what we can do is say, hey, app, is your app offline? Do you have a connection? No? All right, we're going to go ahead and load from the offline cached content. And when you're online, there's also the tricky situation of you want the content fast, but you also don't want it stale. So what we've done is we simply load the first request from the network, which is typically going to get the HTML. And hopefully you don't have a redirect there. You want to try to make sure you're not pointing to redirect, otherwise the first request will be a redirect. But by getting the HTML, you allow for fresh content. So if somebody wanted to, yeah, sure.
Can I ask you a question about, do you pass the burden of knowing whether you're offline or online to the person?
Yes.
Repeat the question.
Yeah, so the question is, do we pass on to the user of the framework the burden of knowing if we're online or offline? And the answer is yes. The alternative is, put some sort of reachability code into our script, but most apps probably already have this, or they might have special needs there. So we just pass that on, and so there's a simple delegate method. Is the app offline or online? So when we are online, we still want the advantage of the cached content if we've already loaded it. So we, as I mentioned, we re-request the first request, but all of the subsequent requests that are associated with that URL will be loaded from the offline cache. So CSS, JavaScript, those will kind of come down the line very quickly because they're just like right off the disk. The nice thing about that is typically a lot of websites use like file name cache invalidation. So if they want to invalidate their CSS, they'll just change the file name, which will invalidate it for us as well. And this is kind of a quick overview of what Mattress looks like. And you have your URL cache, which also has its disk cache, which is where our stuff goes. The URL cache is sort of the standard cache, but also our method that's the public facing thing. So that's really all you see as a user of the cache. And you can tell it, hey, I'd like to cache these 3 web pages. And it'll create a web view cacher for each of those. And as those requests are fired off, they go to the URL protocol or through the URL protocol. And it kind of checks back in with each of these and says, hey, is this your request? And if it is, it will go back through, get saved to disk. And additionally, this also handles when a UI web view comes through, it asks the URL protocol, it can ask back down the line to the URL cache, do you have this saved to disk for offline use? So the implementation of this in your app, you have a pretty simple framework with a nice and simple API. You just create this cache because this is the only public aspect of it. And you set it as the shared URL cache. And then you just tell the URL cache you'd like to cache a web page. So you say, hey, I want to cache google.com for some reason. And it goes ahead and runs that. But when do you tell it that is kind of the tricky question. And when to preemptively cache. You could do it in the foreground. So say in your app, a user is, a use case for this, for instance, was a BuzzFeed app. Somebody sees a post they like and they want to save it to their favorites or like bookmark. You could then fire off a request. Even if they haven't viewed the page yet, you could then fire off that request. And it's going to be a little intensive, but we found that's actually not that bad. You can do that pretty safely. Make that cache request in the foreground of the app. It's probably not a great idea to do it often or without the user actively showing intent to do so. Where we use this in the news app, for instance, is during the background fetch, which if you haven't used background fetch is kind of tricky. Apple essentially says, hey, we're going to give your app time to run in the background. We don't know when we're going to call you, and we don't know how much time we're going to give you, but it's kind of based on how the user uses it, maybe. But it's actually really useful, and what we found in practice is it gets called more often than we expected, and that gives us actually plenty of time. Oftentimes we were able to, on Wi-Fi, cache our entire feed of, our entire news feed of content, which is like 20 websites or so. And so if you're going to be using this in the background thread, just be careful if you're downloading a lot to watch for data usage and battery life, because we found that stuff was getting used up pretty heavily in our 1.0, and we had to throttle back on that and say, all right, let's only use this every few hours. So I recommend keeping an eye on something like that if you use this. And the cool thing was people noticed when we used this. We kind of thought we're playing catch up because we're not using native content. And so this was like our Band-Aid, really. But actually, people really noticed, and it was kind of cool to see that. People saw hey, this is really fast. People would say how are your web pages loading so fast? And it was kind of Mattress was the secret sauce there. And so you should try out Mattress. It's as I mentioned, it's kind of the first, hopefully, of many open source projects. We're working on open sourcing several of the frameworks we use in our apps now, and yeah, so keep an eye out, and yeah, that's it. Any questions? Sure.
So when you delete, let's say that you saved an article, and then you delete it. How do you actually delete everything that is associated with that URL?
So each request, every response is saved associated with that parent URL. So it will, there's sorry, it's actually, I wrote this quite a while ago, so I'm not sure of the complete details, but I'm trying to remember how we did this. But it is associated with that request, and so it can go back and delete all of that stuff. And additionally, actually, this brings up a good point of clearing out old content, which I didn't talk about. What we do is you can specify the size limit of your cache content. So you actually don't have to do that. What you do is set a size limit on the cache, and that's specific to the offline cache, and it's separate from your standard cache, which you can still specify as well. And say you want 300 megabytes designated for offline cache. It'll whenever you cache something new, it'll get rid of the oldest requests. Yeah.
How customizable is the HTTP client? Like, can you pass it a cookie or an authorization header?
How customizable is the HTTP client? Can you include cookies or pass anything in? You are giving it a request, so you're free to do whatever you want to that request.
So you're giving it a request object, not just like a string with the URL.
Exactly, yeah. So it functions much like WebView. You tell Mattress, the URL cache, hey, I have this NS URL I'd like you to cache. Sure.
I might have missed this, but does it have support for e-tags, other cache headers in the response?
It does not do. It is very bare bones. Sorry, the question was, does it have support for e-tags or other like cache response header stuff? It's very naive right now. So it's just grabbing, as far as I recall, I believe it's not doing anything fancy. It's just if you tell it to cache, we're actually like ignoring any like cache expiration or anything like that. So it's just like going into the offline cache, and we make sure to actually ignore that stuff because that's the use case of that is never invalidate this. This is like always unless we're told to re-download it. Sure.
Does it use content blocking? Because you talked about how fast it's loading.
Mm-hmm.
Is it built in?
So the question is, does it use content blocking? So this was all written before you're talking about like the iOS 9 content blocking stuff?
I'm not sure, but because I use the NSURL protocol, and the problem that I had is that it intercepts every single network connection, and it loads the whole page. It actually caches the whole page, including ads, including everything. And
Right.
When I load that, it's pretty slow.
So the question is, do we also cache all ads and the stuff that the user might not want? Yes, we do. We're completely like agnostic about like what we cache. It's just if it's associated with, if you would go to that web page in a UI web view and it would download, we will cache it.
Is there a feature to turn that off?
Like to integrate the content blocking?
There is not, but
V2 backlog.
yeah, it's in the backlog. I'm actually kind of curious if that, because we're stuck with all UI web view for now. I'm not sure like how well that interacts with it, but it's definitely something to look into.
Do you use background fetch for anything else besides the caching?
Do we use background fetch for anything else besides caching? No, but we use it for other caching. So we have the background fetch processes in the News app is more complex than just kick off this NSURL cache. Because first we have to go get the feed, so we cache the JSON, and that gets into our like JSON caching system. Then we get the freshest feed, then go through that, get all the URLs we would like to cache those. We also cache images associated, but it is all caching that we use fetch for, just various different kinds. Sure, question.
Do you have a way of not prefetching analytics tracking pixels?
Do we have a way of prefetching analytics tracking pixels? That's a good question. It will prefetch those depending on, as I mentioned, it's up to the user of the framework to determine when the page is loaded. If you told it you weren't done until DOM was complete, you would probably load those tracking pixels, and you would actually fire those preemptively.
That's what I was asking about. Is can you avoid preemptively firing?
And can we avoid preemptively firing those? We don't have a way to do that right now. What we do, for instance, on BuzzFeed articles when we load those is we have a JavaScript call we can make. So we are able to like hold off on that, but we will actually trigger tracking on any other articles that we don't have a good way to interop with. Question?
Do you know if the new Safari view controller works with the NSURL protocol?
Does
Is that anything that if you use?
So the question is, does the Safari view controller work with this? I actually have not looked into that, but my assumption is that it won't, because it's the idea of that is that it's very hands-off. So I would be really surprised that those requests will be visible to the app.
I have maybe a solution, maybe a redundant one actually, for if you want to use the WK view controller or the Safari one, you can actually use it and use the content blockers with them or anything you want to do. And then in the background, if let's say a person clicks or whatever, for example, my app swipes right. So if you swipe right, the person saves an article. When they do that, I'm using WK, but then in the background, if you save, it runs a UI web view in the background. So when it does that, then the NSURL protocol intercepts everything that happens in the background, and it saves actually the page that they were seeing.
Right. So the suggestion is, could we have the user view the page in WK WebView, but cache using UI WebView? And you absolutely could, but those would be redundant, like caching, which is not so bad. But the problem then becomes when the user comes back and wants to view it, they would still need to view it in UI WebView, because again, if you came back in WK WebView and you want the cached content, you can't get it at WK WebView because you don't see those requests coming in, so you can't respond with your own cached content. So one possibility we looked into was, okay, before the user loads the URL, we check if we have cached content, and then we load UI WebView or WK WebView, depending on whether or not you need to provide your own cached content. And that's a possibility. It was just like looking into the implementation of that, it was just a little too messy. And supporting both WK WebView and UI WebView is like a little more work than it's worth. So we just kept it really simple, and we're using UI WebView across the board in our news app.
Thank you very much.
Cool. Thanks.